Hi there, everybody. Today we're going to talk about maps. This is the second part of the nature geography or the basic concepts of human geography in an AP classroom. When we talk about maps, you guys, maps are flat models that are used to display information about the Earth. Again, they're flat models used to display information about the Earth. In other words, their primary function is to kind of show the spatial relationships that we talked about earlier in class and distribution patterns throughout areas on the Earth. And I'll allow that so you can see that a little bit better. It's written in there for you, but it illustrates spatial relationships. In other words, it shows what's going on within a given area, and it basically shows how patterns develop within that given area on the Earth. So that's the biggest thing that we use maps for within this classroom. But the nitty-gritty of it, again, make sure you get the definition that they're flat models used to display information about the Earth. We used to just say flat pieces of paper, but of course with the digital age we live in, our screens can also display maps as well, still on a flat model format though. Now, some parts of a map that you're used to seeing. Okay, one part could be the legend. That's probably the one most of you are most familiar with using through the years of school, all the way back to your elementary years, to your middle school, to now your high school years, and college years, if we want to call this AP class as a collegiate course. But a legend is a key used to explain the symbols on the map. So again, it's a key that's used to explain the symbols on the map. Sometimes we use the phrase key, in fact, to call a legend what it is, you guys. But basically, we have these symbols that give identification to a map. I'm not going to take the time to show that to you because I think most of you would know if we're looking at a map of North Dakota and there's a star next to Bismarck, we would know that that star, looking at our legend and understanding the key, we would understand that that star, represents a state capital. Orientation. This refers to the basic directions on a map through the use of a compass rose. So it refers to the basic directions on a map through the use of a compass rose. And I can show you one of these in class as well, but basically it's showing you which direction north is, south is, east is, west is. Later on we'll talk about this. North doesn't always have to be the top of your map, and there's a couple different displays within your book that you can see this. They're going to ask you to draw them out in your key issue packet as well. But when we talk about orientation, we're talking about the basic directions on a map indicating the directions of north, south, east, west within a compass rose. That's kind of the symbol that uses that to show us orientation or to show us direction. So when you think of orientation, think of directions. Scale. Scale illustrates the actual size, distance, and level of detail of a particular place. So there's many different things that scale can represent, but it can be the actual size. For example, sometimes they'll show the size of France within the United States, because many of us have a good understanding within our head of how big the United States is, and then we see the country of France in it. It gives us just a better idea of how big France could be. So that would be what we're talking about when it illustrates the actual size. The distance, many of us have done this probably in our later elementary years and middle school years, where 1 inch represents 500 miles, and we had to make a little inch mark on a white sheet of paper and then determine how far it is. So again, distance and the level of detail of a particular place. Now that's the one I want to go into more emphasis on, because we'll be looking at a variety of maps, and these maps can either be large scale or they can be small scale. Okay, if it's a large scale, again, the keywords here are large scale, you guys. That means there's many details to less area of land. You can't cover as much land. There's more detail to it. And again, I'll show you some of these examples in the classroom, or your book will show you these examples, and your key issue packet will talk about these examples. But when we talk about large scale, we're basically saying that there's a lot of details, but because there's so many details, it covers less land of the Earth. All right. Small scale is just the opposite. There's going to be fewer details. Okay. Again, the keywords are small scale. That means fewer details on the map. Therefore, it can cover a greater area of the Earth. So again, smaller details or less details for a larger area of land. And that's what we're looking at between the two. And again, this is when we talk about scale, I know that's been asked on the AP test quite often. Understand large scale means a whole lot of details, but because you have so many details, you can't cover as much land. Small scale is just the opposite, you guys. There's fewer details, which allows you to cover a greater amount of land on the Earth. Okay. Now, formatting scales on page 22, you can look at your book in regards to this, and I'll turn to that as well right here. You can see there's different types of scales when we're talking about formatting. In other words, trying to adjust the image to our page in a book, for example. And so we take a look at that And we look at that at page 8 in your book, you guys. You can see there's different types of formatting scales that exist. You have the ratio or the fraction. Again, most people refer to it as the ratio scale. You have the written scale, and you have the graphic scale. And looking at this, you can see a couple different blends as we look at this, and I'll kind of highlight with the pointer right here. In the top right-hand corner on the Google Earth, and you can look at any of these maps, but it says 1 to 10 million, 1 to 1 million, and when 1 to 100,000 right there, you guys. What you're seeing is less Earth being covered. Again, we're talking about as that number gets smaller, we begin to see more large-scale format pictures take place. In other words, we're going to see more and more details as that ratio declines. But basically, when we talk about ratio, we're talking about the relationship of that one page, you guys, and how much of the Earth is being shown on that one page. And so that's kind of what we're talking about with the ratio right there. Sometimes, again, if you look in the bottom left-hand corner, it refers to what we talked about with those mile markers before, you guys. When we talked about that, here's where we have written, for example, 1 centimeter equals 10 kilometers, or in this case, you could say basically you got about, again, we're looking at it right here. This distance from here to here doesn't actually give the distance. We'll say it's an inch or a little under an inch, represents 20 miles. So again, that's an example of written formatting scale. And then the graphic is a bar line that represents 500 kilometers. And so we get down to the last one, and we can kind of see that same concepts taking place right there. So again, not a lot of things to talk about. I'm probably spending more time on this than we needed to. But when we take a look at the scales, just know that when we're formatting scales, you guys, numbers kick in, and we have to look at it. So we can say one page equals, this page represents 1 million kilometers of the Earth. Again, an inch represents 10 kilometers. Again, you get the idea of what we're talking about right there. So just understand the concept of scale. But again, when we're talking about scale, large scale, small scale, by far and away more important for you to understand where large scale is lots of detail, but less area of the Earth, where small scale is just the opposite of that. Projection. Talk about this quite a bit in our world cultures class as well, and you probably talked about it in your geography classes for those of you that had geography at Ben Franklin in 7th grade. Whenever we talk about projection, we're talking about the process of displaying a round Earth on a flat surface. So we're talking about the process of displaying a round Earth on a flat surface. What I would like you to do is I'd like you to understand that there's different types of projection. This little YouTube video link right here that you can see on the page, I'd like you to put that in, take a look at that, make sure that you can identify the different types of projections that are offered. I have found on the AP testing, you guys, that they're getting less and less specific for you to have to identify, is it Mercator projection, is it Peters projection, that sort of thing. So when we look at that, that's something that I want you to understand. So you are going to have an opportunity to look at that link. Then that's projection, and basically what it's basically telling you is it's how it displays the Earth on a flat surface. That's what projection is in a nutshell. Now, because we're taking something that's round, you guys, or three-dimensional in form, and we're flattening it out, certain errors are going to occur when you try to show a round Earth on a flat surface, and we call that distortion. Errors that occur when attempting to display a round Earth on a flat surface, okay? So these are errors that occur when attempting to display a round Earth on a flat surface. So regardless of what you're using, unless you're using a globe itself, a three-dimensional globe itself, you guys, we are going to have distortion take place regardless of which form of projection map you're going to use. Now understand that some of these projections are better than others. Again, that video on the YouTube clip will kind of explain that for you. Your book does a nice job of explaining that, and your key issue pack is going to ask you to explain the various types of projections that occur by using Mercator through Peters, etc. But also understand that certain errors are going to occur when attempting to display a round Earth on a flat surface. So basically, if you're trying to correct one spot that's being distorted, something else becomes distorted along the way. The West Wing clip right here, it's a Netflix show, deals with a made-up presidential administrative team, cabinet, if you want to call it that, and basically all the issues that they have. And they're going to be a union of cartographers are going to come in, and they're going to talk about how the present projections that we're using in our school systems are misinforming our students, or you guys, where certain places are actually found on the Earth. So it's kind of a little fun clip. map. World culture students, you've seen this clip before, so you may not want to watch it again. But for those who haven't seen it, it really does a good job of identifying distortion. As I said before, a globe, unless we're using a globe, you guys, we're going to have projection issues such as distortion kick in. A globe is the best model to use when studying the Earth, but it's unrealistic. We can't carry our big globes with us, you guys. We don't have them immediately available like we do when we put it up on a screen or through a sheet of paper or something like that. But a globe is the best model to use when studying the Earth. Definitely want to know that. Now, there's different types of maps. In our world cultures class, we focused, and probably in 7th grade in your geography class, you focused on using political maps. Political maps, you guys, are used to outline the boundaries or borders between two or more places. So if we take a quick look here, here's an example of a political map, again, you guys, where it outlines the boundaries or borders between two or more places. This is a world map, and again, it has a variety of colors. So if I look at Canada, I can quickly identify, okay, here is the boundaries, here are the territories or possessions of Canada, all in this orangish color right here. And then its neighbors, you can see the United States is in green. It indicates Greenland or Denmark, again, with that frozen ice mass right there being in white. But it does do a good job of identifying the borders or boundaries. You can clearly see how the particular country or area of the world looks. That's what a political map is all about. A physical map, going back to our notes right here, is it illustrates the topography of a given area. Topography, we're kind of talking about the physical features, the relief, the elevation. So it kind of illustrates the topography of a given area. By topography, again, we're talking about physical features. These are your landforms and other bodies of water. So next to physical features, you could put landforms and other bodies of water. Relief is the level of ruggedness over an area of land. So basically, it tells us how rugged or how flat the land is. Some of you have seen these with globes before. You've had those maps where you go over the mountains and it's bumpy right there and it's got that rugged feeling to it, letting us indicate that, okay, this is a mountainous region right here. It isn't completely smooth and flat across the world. So it shows us the level of ruggedness over an area of land, and it can physically do that with these bumps that indicate where the mountains are, and I think most of you in your elementary years have seen that. I have a globe in my room that shows this as well. And it can use colors as well. Elevation is another thing. It's a height above or below sea level. So when we talk about a physical map, it really shows the topography of a given area. Either it's landforms, bodies of water, the ruggedness, the flatness of land, the height above or below sea level. All that is included within a physical map. Distribution map. This map illustrates the amount of something within a given area. So it shows the amount of something within a given area. This is going to be our most used map in our AP class, you guys, in AP Human Geography. This is going to be the most used map that we have because it's, again, going to show the amount of something within a given area. And so it shows us the concentration, the density, it shows us the patterns that have developed within a particular area. So this is what a distribution map is all about. Now, looking at our pages right here, we can see what a distribution map looks like right here. We have modern distribution map of world religions. You can see, for example, the darker maroon shows Roman Catholic, the pink shows Protestant. We can look at different types of religions that are being formed here, with Islam being the greenish colors and the different types of Islamic practices that exist right there. So this is a good example of a distribution map, even especially since the word right there in the title says distribution of world religions. So that's what we're looking at right here. Other distribution map examples that we have population density map. This shows the number of people within a given area. So the number of people within a given area. We'll go in population figures and different types of population density maps later on. But for right now, just know that it's the number of people within a given area. Vegetative, it shows the plant life or illustrates the plant life within a given area. Land use, it illustrates the overall activity. Most of the time we're talking economic activity within a given area. So population density, again, reviewing these really quickly, number of people within a given area. Vegetative shows the amount of plant life within a given, the amount and the type of plant life within a given area. Land use illustrates the economic activity within a given area. And then, of course, climate shows the usual temperature and precipitation patterns within a given area. So it shows the usual, that's what climate is, usual temperature and precipitation patterns within an area. So this is what we're looking at when we're looking at maps, you guys. Some other things that we use in order to understand, they could be on maps themselves or just more tools for geography that we'll be using in this classroom. We talked about building a hospital in San Francisco later on as one of our projects, you guys. We'll be using the geographic information science then, or system, we could say. Geographic information science is the acquisition and analysis of data about the Earth, okay? So it's the acquisition and analysis of data about the Earth. And we're usually using some electronic technology for that. So it's the electronic acquisition of information being analyzed and acquired about the Earth. So the acquisition and analysis of data about the Earth is kind of what we want you to put down for GIS right there. When we look at this now, you guys, we can talk about GIS most of the time, and I got to use one of these when I went and visited my son, or when he went on a college visit to the Minnesota Crookston. They actually had a GIS machine, which basically stores and collects data within a system of complex layers. Now, he wants to go into pre-med, and what they could do is they don't actually get to work on the cadavers or the dead bodies dedicated or donated to science, you guys. So what they ended up doing is they have one of these machines where they can look at layers of the body. So you could look at the outside of the body itself from the skin, or you can electronically remove the skin, which shows then other parts of the inner organs at work then, and you can get deeper and deeper into the body by just removing the layers. And then you can put the body and restore it back to its original frame by adding those layers at the same time. Think Google Earth. Google Earth allows you to do this all the time. And you'll have a chance to play around with Google Earth in class, especially when we're talking about that project I keep referring to when we talk about building a hospital in San Francisco. There's two types of data that's gathered, you guys. We have the vector data, which consists of points and lines, okay? I know this is going to sound a little confusing, but this consists of points and lines. And when we talk about points and lines, really, to make this simpler for you, when we talk about points, we're talking about cities. And when we talk about line, we're talking about highways, okay? So this consists of basically the cities and highways. This is one layer. We can remove that layer, and what it will do then is it will show us the landforms of the Earth, and that's called the raster data. The raster data is going to be the features or landforms of the Earth. So when you think of vector, think of cities and highways. When you think of raster data, think of features or landforms on the Earth. Okay, essentially what we hope to do and what we end up doing with this, you guys, and you're going to do this with your project when you build that hospital in San Francisco, is you're going to combine several types of these two forms of data together. So you're going to use the vector and the raster together, and they're going to overlay on one another, and that's going to give you a good, clear map to use. Okay, so that's what we're looking at right there. The next thing we're going to use in class is called the remote sensing. Okay, this is when we scan the Earth by satellite or by drone or by high-flying aircraft to obtain information. So again, we're talking about the scanning of the Earth by satellite or drone or some form of high-flying aircraft. GPS, Global Positioning System. Most of you are somewhat familiar with that. For those of you that are fortunate enough to have your own device or your own phone, this electronic system is used for navigation. It helps us to find our way around the Earth. Okay, so it's used for navigation to help us find our ways around the Earth. Last but not least, and then we'll conclude this podcast, the geographic inquiry process. Our world culture students use this quite a bit in every project that we do. In fact, the first thing we ever asked them to do is use the geographic inquiry process to purchase a house. And essentially what this is it's the 5 steps of critical thinking. Okay, here for you it says a 5-step inquiry process used within human geography. I would simply say it's the 5 steps of critical thinking. This is where you're going to it is, what do I want to know? How am I going to find this information? How do I arrange or organize this information? What does this information mean? And what conclusions can I reach once I've figured out what all this information is and I arranged it accordingly? And that's basically ask, acquire, organize, analyze, and act, as you can see on your sheet right there. So this is maps and other tools of geography that are going to be useful. We'll talk about them from time to time in class. Definitely a lot of vocabulary, something that you want to go through. And don't forget to look at those 2 links, especially the ones talking about the Mercator projection, Robinson projection, Winkle triple projection, and Peters projection. And then, of course, that West Wing clip does a really nice job of showing what distortion is and how it works on the various maps that are used within our school systems today. With that, I conclude our podcast on maps, and we'll see you tomorrow.